Okay, so now I'm over on page 73 looking at just a couple more examples that go along with the first part of, or with 2-5 here. A complex conjugate basically is to say when you have a complex number, which we just got done talking about, something like 5 minus 6i. Okay, let's do 5 plus 6i. The conjugate of that number is basically the same real component, so I'm not changing the sign of the 5, but we are going to change the sign of the imaginary component. So I do not change the sign of the real component, I change the sign of the imaginary component. So in our first example here, 3 plus 5i, the complex conjugate is going to be 3 minus 5i. Don't change the sign of the real component, change the sign of the imaginary component. Okay, if I look at the complex conjugate of negative 6 minus I, that's going to be negative 6 plus I. Do not change the sign of the real component. The complex conjugate of 12. Well, 12 would be like saying 12 plus 0i. Okay? That I component, the imaginary component, doesn't exist. So if you think of it as 12 minus 0i, we're not going to write the 0i once again, but I'm also not changing the sign of the 12 because the 12 is the real component. And then lastly, negative 2i, that's like having 0 minus 2i. So my complex conjugate would be 0 plus 2i. I'm not going to write the 0. I'm just changing the sign of the imaginary component. Now the little reflection question here is interesting. And maybe you want to pause this for a second just to, try to come up with an answer for this. But what is the conjugate of the conjugate of a plus bi? Well, it's just going to be a plus bi again. Okay? Because, oops, I forgot the C. The reason would be because the first conjugate would be a minus bi, and then the second conjugate, or the conjugate of that, then goes right back to where it came from, a plus bi. So you're just kind of like taking the conjugate once, and then you're getting the same conjugate back. Okay, now example 4 here, we got to take a step back and think about the quadratic formula. Now you all did this in Algebra 1. We're not going to take time reviewing how to do the quadratic formula, but we need to know what it is. So I don't know if you sang a song or not, but I'm going to sing a song for you. It's the Pop Goes the Weasel song. I'm sure some of you have already heard it, but here it goes. X equals opposite b plus or minus the square root b squared minus 4ac all over 2a. Once again, that was x equals opposite b plus or minus the square root b squared minus 4ac all over 2a. A little faster. X equals opposite b plus or minus the square root b squared minus 4ac all over 2a. Sing it, sing it, sing it. Refresh it. Take care of it. Now, what is a, b, and c? Well, think about standard form quadratics. ax squared plus bx plus c. There's your a, b, and c. A is the number in front of the x squared. B is the number in front of the x. C is the number that's without x, a constant. We never include x's when we're substituting here. We use numbers. So in this case, even though it is x squared, there's an understood 1 right there. So my a is 1, B is -4, so be careful of that sign. And C is 5. Now, I don't really love the way that they have this laid out, because when I sing the song to myself for this, I sing it as x equals opposite B, knowing that whatever my B is, I want the opposite of that. Okay, so I know this is going to be 4 because it's the opposite of B. But because they already have this set up, okay, they already have the negative there, I'm going to put -4 here. So yes, it's going to look like I'm plugging in -4. Remember, when you have a minus and a negative, it becomes a positive, so that's why I have +4 here. It is what it is. X equals opposite B, so I took the opposite of B. It's just in my first step I had to actually put it as the opposite of -4. Alright. So inside here now I'm going to do B squared, so I'm going to make sure to put... Oh, something just got updated. I'm going to make sure to put -4 here in parentheses. Okay? In parentheses. -4 times A, which is 1, times C, which is 5, all over 2 times A, which is 1. I'm going to repeat the same numbers over here. Once again, this is not something I would normally do. I would not write this out as 2 separate parts. I would just use the plus or minus feature. But it's the way they have it set up here, so I'm going to oblige by it. Okay? The reason we're writing it twice is because in our quadratic formula, there is a plus or minus right here. So they just did one of them with a plus and one of them with a minus. That's the only difference with these two. Now, if you plugged it in and just used the plus or minus sign, you don't need to write it twice like this. All right, so this is a 4, +4. My denominator is going to be 2 because that's just 2 times 1. And now I need to figure out what's under my radical. My advice is this. You grab your calculator, you put this whole thing in, you put the whole thing in without the radical, with the parentheses, and you just punch it in and see what you get. You do open parentheses, -4, close parentheses, squared, -4 times 1 times 5. Put it in. When you do, you'll see that you get a -4. Okay, that's what comes out when you put the highlighted part into your calculator. So now this is where, before now, you would have quit. You would have said, oh, negative under the radical, no solution, I'm done. But you're not done, not anymore, because we introduced these imaginary numbers. So I'm not ready for that last step yet. To me, they kind of skip a step here. So I'm going to put a little equals with an arrow saying, okay, what does this become now? So I still have the 4 plus, and I still have the 2 down here. I still have the 4 minus, and I still have the 2 down here. But the question becomes, what is the square root of -4? Well, whenever you have that negative, remember, you can take that and write that as a product of 2 different numbers. You can write it as 4 times -1. Okay? Once you do that, now you can split it up and write it as the square root of 4 times the square root of -1. I know the square root of 4 is positive or -2. I know the square root of -1 is my new best friend, I. So really, that all reduces to 2i. 2i. Okay? Now, you will find yourself getting more comfortable with that to where you don't have to write that out. You can just go to it. All right? Now, I'm still not ready for their last step here because for me, and I certainly 100% encourage you to do this. When you have a binomial divided by a monomial, in this case 4 plus 2i divided by 2, I'm going to take the 4 plus the 2i, and instead of writing that over one big long division bar, I'm going to split it up and divide each part by 2. Okay, I'm going to split it up and put each part divided by 2. Because now, when I do 4 divided by 2, I get 2. And when I do 2 divided by 2, that's where I get 1 and I. So 2 plus I is my solution. Same thing over here. 2 minus I is my other solution. Notice, these two here, these are conjugates. We talked about that at the top of this page. The reason I bring that up is because when you have a negative under a radical, you are going to have conjugate answers. You're going to have conjugate answers. So you don't really need to do the whole process twice. Okay? You don't really need to do both of these. You could have, don't X yours out, but you could have just done this part here, come up with your answer, and known that, oh, it's going to be 2 plus or minus I. Alright, instead of doing both of these, you have a negative 4 plus or minus all of that. You have a negative 4, or I'm sorry, a positive 4 plus or minus that. This is a plus or a minus. This is a plus or a minus. Your answer is a plus or a minus. So you don't really need to do this in two separate steps. And I'm guessing that when you did quadratic formula in Algebra 1, you probably didn't do it in two separate parts. You just keep the plus or minus as you go through. I would suggest we do that instead. Okay, we're not going to worry about graphing these down at the bottom. Okay?